Okay, so today, guys, we're going to talk about the legacy build. You asked, we answered. We're talking about all the nitty-gritty details that went into this build and all the tough things that we had to jump through and fitment-wise and getting the BRZ transmission to work and things like that, and sort of the reasons why we did what we did and why we configured certain things and why we chose our engine and transmission and things like that. So let's get started. So first off, let's talk about the engine. So the H6 that we used is an EZ30D. It is not the EZ30 with the AVCS or the drive-by-wire. It's just your super standard 01 to 04 EZ30D that is cable throttle only. Really easy to swap. And the reason why we chose that rather than the one with the drive-by-wire is mostly for ease of getting the electronics to work in the donor car and not having to mess around with the pedal assembly and getting all that calibrated and things like that, and it's just a mess. So we chose to go with the easier option. Yes, it doesn't make as much power as the car with AVCS and things like that, but it still makes plenty of power for what we have it in. The motor was never designed to work in the BG chassis, if I'm correct on that. They were in the 3rd gen and later chassis, so the nose end from the distance between where the engine mounts are and the front of the core support is a lot shorter in the 2nd gen Legacy than it is the 3rd gen Legacy. So the main problem we ran into with the fitment of the engine is the fact that you can't run the standard radiator fans with that in there. But luckily, we live in Oregon. I don't really care about having air conditioning because there's a lot of extra wiring and things that I would have had done anyway. So I got rid of the condenser and then I modified the factory fans to fit up inside the core support and then mounted them inside the core support and reversed the polarity of the fans so that they're pusher fans instead of polar fans. So that solved our problem. The other issue that we had engine-wise is for cooling, the radiator on the EZ30s have 2 inlets and 1 outlet. Because the crossover tubes that are on the top of the block, there's 2 outlets that feed back to the radiator. So what I did was I modified the core support. I just notched out the bottom of the core support so that we could drop the factory EZ radiator, the LL Bean radiator, into this location, and it worked out just fine. A lot of guys, they will take the 2 tubes and connect them together and then run them into the single inlet radiators. But you really reduce your flow when you do that, so I wanted to stick with the factory setup, and plus it just makes it a lot easier for trying to figure out all your radiator hoses and such like that. This motor, coming out of an 04 LL Bean Outback, it made about 212 horsepower and about 210 foot-pounds of torque, which is a significant increase over the 2.5 liter that originally came in this car, so quite a bit different. It is a chiming chain motor, so you don't have to mess around with the belts or anything, and basically that system doesn't really need to get serviced throughout the life of the motor. It is a MAP-based system, so manifold air pressure-based system. It does not have a mass airflow sensor. It just uses an intake air temperature sensor and a MAP sensor to calculate your air-fuel ratios, and it's actually a much easier system to deal with because you basically can't have vacuum leaks. So you have a lot less vacuum lines, a lot less complexity in all of your intake piping and things like that. What else? Let's talk about modifications. We really haven't done much of the motor as far as modifications go. A lot of you guys noticed that we have sort of a funny thing going on with the intake. Basically, I just made a pipe that comes right off the throttle body and connect the intake pipe right to it. And I wanted to do that because the Legacy GT has a hood scoop, and so what I did is I took the hood scoop dam out of the hood and then I used that to feed cold air into the intake. I could have just as easily modified the stock airbox and ran the stock airbox for this, but I kind of wanted to do something cool and different, and it makes all these cool induction noises, and as you guys could hear from the video, it makes all kinds of fun sucky noises and things like that. And it's actually kind of neat because when I hook up my scanner tool and I run, I look at the intake air temp, I can actually watch it drop as I start driving, and it will drop down almost to ambient, maybe like 1 or 2 degrees above ambient while I'm driving. So it actually makes a really significant difference, and you're really drawing in all that cold air from the outside right through the hood scoop. So it's really the best place. Exhaust wise, it's actually really simple setup, and it's not far from stock. I know these engines don't make very good noises when you take the catalytic converters off, and plus I wanted this car to be able to pass CEQ if I ever needed to, so I left the stock cats on, and it's actually the stock cats and part of the stock headers for the 2.5, so that I wouldn't have to fab up an entire set of headers and things like that to get the exhaust out the back, because of the different lengths between the 2nd gen and the 3rd gen chassis. So what we did is we actually scabbed in, we took the collector, because the EZ30s, this model does not have 3 exhaust ports. It only has all the exhaust ports feed into one big triangular flange. So it makes it really easy. We took the collector from both banks, and then we just scabbed in the factory H4 headers to the rest of the piping and used the factory H4 cats. And then all that does is feeds into a, and actually it feeds into a Flying Miata exhaust, just a resonator, that's all it is. So it's basically, it's got the cats and then no factory resonator or muffler anymore, and it feeds into an aftermarket glass pack style resonator. And I love the sound that comes from it. It's not super loud. It's not raspy at all, and it makes a nice crackle and pop when you come off the revs, so it's actually a pretty neat sound that comes out of it. The other thing that I did to make it easier for us front end wise, I really wanted to keep all the Legacy GT power steering components, and I didn't want to change the front end wiring harness for the GT, so I used the factory Legacy GT alternator as well. And all I did was I swapped the pulley off. The alternator, the H6 alternator pulley is a little bit longer, so I just had to machine maybe 1/8 of an inch off the back face of the pulley, bolted it on, and it bolts right up in the factory location, so that one's easy. The power steering pump was a little more difficult. I did want to use the factory steering pump just because it's valved for the rack and pinion that's in this, so I didn't want to have to build custom lines and things like that. For the pressure side, I'm using the factory reservoir and pressure and return lines from the LO beam, and that is just mounted in the same location that it would have been in the LO beam on the frame rail on the passenger side. And I made myself a little adapter flange that bolts on, so it basically removes the reservoir tank that normally sits on the top of the power steering pump, and I just put a NPT line to a barb, and that's how it pulls suction from the reservoir into the pump. And then pulley wise, because the H6 has a 5-rib belt and not a 4-rib belt, what I did is I took the hub part off of the pulley, so I removed both pulleys. I machined out the barrel on one, and I machined out the hub on the other, made it a press fit, and then stitch welded the back side, and it's perfect. It's good to go. Runs nice and true. Runs great. Everything's sitting in the correct location, so it's not pulling the belt a weird way or trying to track it off. And actually, it runs just fine. Next thing that everyone's asking about is the BRZ transmission fitting to the EZ30. This was a fairly easy thing to do as far as transmission conversions go, because it didn't require an adapter plate or anything crazy like that. The dowel pins line up with the locating pins with the block into the transmission. The input shaft for the transmission lines up with the back of the crank, and Subaru didn't change the pilot size for the bolt pattern for any of the flywheels that go on the back of the crank. So we were actually able to use the factory FRS. I just bought like a 2015 FRS clutch and flywheel assembly, and I was able to use the factory FRS clutch and flywheel with the FRS throwout bearing and the FRS slave cylinder, and I just attached the master cylinder to the slave. Made it super easy. For the clutch, But the one thing I did notice was that because there's a little bit of a mismatch on the cylinder size for the master to the slave cylinder for the clutch, I did have to take the over center spring off because it was too much pressure and the clutch was too light. So with the over center spring, the clutch would stay on the floor and it wouldn't return. So took the over center spring off, now it feels great. It grabs a little bit high, but I think that's just because it doesn't have a lot of throw on the clutch. To fit the transmission to the engine, because the starter's on the opposite side, what we ended up having to do is notching out the flange side of the block to clear the nose of the starter, and I did this with a block, an EJ block that I knew was ruined first, just to kind of prove out the concept, because I didn't want to cut into the H6 if it wasn't going to work. So I proved it out with the EJ and then kind of took a form off of that and stenciled it onto the EZ and then just cut away the nose of the block, and I just kept fitting the starter up until it cleared. I basically just radiused it like this to clear the nose of the starter. It does kind of break through the backside, so this will end up being open here and this will end up being open here, looking at the top of that flange. So the front of the starter does kind of hang out the backside, but it doesn't interfere with anything on the front side of the block there. The upper hole on where the starter mounts in is a through hole, and it actually does feed into a threaded hole in the block, but the lower hole, because of the way things are configured, it doesn't go into a threaded hole in the block. So what I ended up having to do for that was taking the starter and the lower through hole on the starter, I opened up to a through hole size, and then I tapped the through hole on the bell housing for the next metric size up, and then just bolted the starter straight into the bell housing using that thread. And so that way I maintain all of the mounting locations for the starter, and I think we ended up with 5 out of the 8 mounting bolts for the engine to the transmission, which is plenty to hold the thing together. Other thing that we had to do was, because the FRS is configured a little bit differently as far as engine and transmission location, there's a bunch of extra webbing and structural support that's casted into the bottom of the bell housing that had to be notched away to clear the cross member. The input shaft for the transmission is in the center here. This is your starter hole looking at the face of the transmission. All I had to do was notch about 1 inch this way and about 4 inches this way on both sides of the bottom of the bell housing. And that gave me enough clearance because on the Subaru crossmember it's kind of shaped like this. Right, so the crossmember is kind of shaped like this because your engine mounts go here and here. So notching that out gave me the clearance to drop the transmission down into this location here. Next thing we ran into is, of course, there is no crossmember that works directly with this chassis for the BRZ transmission, the FRS transmission. So I ended up having to fabricate my own, and basically all I did was took the manual transmission crossmember that's factory to the Legacy, and I notched out a section that was closely lined up to where the factory transmission mount bolted up on that transmission, and then I fabbed myself up using some like 1x1 by 125 wall square tube, which is probably way overkill, and I just fabbed something up that I could weld directly to the transmission mount, and it was super easy to do. I made sure before I welded everything up that I had proper clearance between the top of the transmission and the transmission tunnel, and the engine and transmission were sitting at the proper angle before doing so. But I just kind of put an angle finder on the output shaft of the transmission and then stuffed some wood blocks up above and then tacked everything together and pulled it down, full welded it, and it was good to go. Shifter was relatively easy to mount up. I did have to clearance a section on the top of the transmission tunnel where there's like a hump in the shifter mechanism for the transmission. I had to cut a section out where it enters the opening for the shifter. It does sit like 1.5 inches further forward than the factory shifter, and all I had to do was for the rear mounting location, the body mounting location, was add some spacers to it and bolt it directly to that, and then I just kind of modified the rubber boot that works with the FRS to fit right into that location. So it actually mounts up pretty good. I still don't have anything like decorative boot wise on that area. I don't really care about looks, so I may not ever, but we'll see. Drive shaft. So the drive shaft was a little bit tricky just because the FRS transmission is even shorter than the standard all-wheel drive transmission. So your distance ends up getting even longer for a drive shaft build. And I actually started out having a custom one-piece drive shaft built with 1310 series U-joints. And because you don't have a lot of room in that transmission tunnel, because they weren't really designed to run a very big diameter drive shaft, I was hitting these really horrible harmonic vibrations, which is basically a result of not having a big enough diameter tubing and trying to span too long of a length. So what I ended up having to do was go to a two-piece drive shaft, and in the two-piece drive shaft, I utilized the FRS carrier bearing, which actually bolts right up to the factory location for the Legacy chassis. And I used the spline side, and we just machined that end off and then welded it to the slip yoke for the 1310 series U-joint, and then the opposite end had basically just more 1310 series U-joints. And we did have to adjust the diameter of the tubing a little bit because we didn't want to hit that harmonic vibration again, but once we got all that squared away, it worked out perfect. So just got to be careful with that because it is a very long distance between the centers on the U-joints. So that's something that a lot of people don't consider, including me, when you're designing a drive shaft, because all that stuff has to be calculated before you build. The rear diff is, everyone's going to laugh at this, it's just a factory R160, but I'm not drifting it, okay? I'm not clutch kicking it all the time and beating the crap out of the thing. So yes, of course, the longevity is going to be reduced because it's only a 160 millimeter ring gear, and there's not a lot of teeth on there, so there's a lot of load because now we're driving the rear wheels with just the R160. But the other advantage that we have is that it is a viscous limited slip R160, and so that way, you know, it's not a welded diff, so it's not transferring all the shock load to one wheel or the other, or beating the crap out of the axles or skipping in parking lots. So we'll see how long it lasts. If it does blow up, I'll probably end up upgrading to an R180. So the biggest pain in the ass for the whole swap, and the thing that I spent the most time on, was the wiring. It is not an easy feat, and a lot of people have to end up doing it themselves just because no company like iWire, who usually does merges for turbo swaps into non-turbo Subarus, they won't touch it because the car won't run like factory once it's together, because there's almost no configuration with an EZ30 that used a manual transmission. So the ECU is constantly looking for the TCM communication. There's a couple ways around that. What you can do is, I've seen some guys build resistor packs that plug in to the TCM, and basically that simulates the load of the solenoids, the duty solenoids in the transmission, switching back and forth, so the TCM still thinks it's doing its job. It's still changing gears and whatnot. It's just not getting all the feedback that it needs. I think the simpler way is to flash the ECU. I found awesome guy, his name's Gabe Corman. He takes the EZ30 ECUs, you tell him all the codes that it's throwing that have to do with TCM communication, and he shuts them all off, and he adjusts all the load tables to make the transmission happy, or the engine run happy with the load of a clutch and flywheel as compared to the load of a torque converter, because torque converters are inherently always putting load on a car, where a clutch and flywheel will just spin once the mass is rotating at whatever speed it's going to. So the car will have a tendency to try and overshoot the idle target because it's not seeing the extra load that the torque converter puts on it. So sometimes the car will die, it will idle all over the place. But the other thing that Gabe does is he bumps the idle speed up to 800, and that allows the ECU to have time to dictate when to start engaging the idle. So that gives the ECU some better response to changing RPMs, especially since these engines wrap up and down the rev range really fast. So that was awesome. He's super good at it, really reliable, does a great job. So the merge itself, what I ended up doing was taking the entire harness out of the donor car, front to back, which realistically you only need the dash bulkhead section. There's a lot of write-ups and there's a lot of how-to videos on doing a generic Subaru wiring harness merge, and for the most part you can follow that. That's what I did. I found a good write-up on how to splice out the donor harness, and you're basically just splicing the engine bulkhead section out of the dash bulkhead that runs through the firewall out to the engine, and a couple extra things, and then all the wires that run away from the engine to other locations, you snip them off and give yourself about 18 inches on each side, and you label them all. So you download the factory service manuals and you just pull up all the diagrams and you trace everything back. It's excruciating, and you trace everything to the pins and then label them. And then to get your donor car ready, you do basically the same thing. So you rip the bulkhead section out from behind the dash, and then you splice out the old the engine harness bulkhead for that, and then you splice in the H6 engine harness bulkhead and start connecting all your inputs and outputs to make everything happy. So a couple things we ran into electronically is obviously the tach is a 4-cylinder tach, and we now have a 6-cylinder. So I used a Dakota Digital tach converter, which you can basically go 0 to 12 cylinders, any input to any output, and I just told it that we're running a 6-cylinder, and then it does the conversion to make the 4-cylinder tach happy. The other major issue that we ran into is the FRS and BRZ transmission does not have a vehicle speed sensor, because everything past 08 is CAN bus style. So they all pull their vehicle speed data off the wheel speed sensors for the ABS. So a company called Map DCCD makes a solution to that, where they make this conversion box that takes the square wave that the older style wheel speed sensors generate for the ABS, and converts it to the pulse wave that would normally come out of the 3-wire vehicle speed sensors that feed to the ECU. So once you wire that in, so you pull data off of 2 wheel speed sensors, and I chose to use the rear because I'm now driving with the rear wheels, and if I did use the front, if I was, drifting or doing a burnout, basically there'd be a mismatch to the RPM position and the vehicle speed, because the vehicle's revving crazy but not moving, right? So I used the rear wheel speed sensors, spliced into those to power the converter box, and then that converts the signal to what the ECU can read, and then you splice that off to the cluster, and then that powers also the speedo. You can calibrate it as well. So all I did was had a buddy that I paced on the highway at 60 miles an hour, and I just bumped the calibration up and down to make sure I was sitting right at 60, and the thing works beautifully. So that was a nice, easy fix for that. And then the ECU stays happy because it needs the vehicle speed to calculate certain loads and things like that. So if you don't supply it with the vehicle speed, you have all kinds of weird drivability issues. Our swap was pretty straightforward. I chose to do as easy as possible. Obviously, the more more features and things that you want to keep, you add complexity to it. So people who also want to keep the air conditioning, if you want to keep the cruise control, that really makes the wiring harness merge way more complex, because you have to make all those systems happy, and you have to choose which systems you want to supply for the merge. So I just decided to do a straightforward swap. I just wanted the engine to run in the car and run good, that I can drive around and have fun with. So that's what we ended up with. I did do it myself. I'll probably never do it again because it was really hard. But other than that, I mean, this swap was pretty straightforward. It is an amazing power gain. I mean, it sounds like no other Subaru because it's an H6, not an H4. And with the nice tight gear ratios on the 6-speed transmission, it really complements the engine. So it was a lot of fun. So check out our video, guys. Tell us what you think. Like, comment, subscribe. See you in the next one.